Supreetha. Welcome to my math class. So in the previous lectures on Laplace transform, we studied the definition of Laplace transform. Yes. And then we solved some problems. We saw some formulas of Laplace transform, the basic formulas. Yes. And in the previous videos, we studied shifting property. When do we apply shifting property? When we have the question in the form e power at into f of t. We apply what? We apply shifting property. Okay. Now in today's class, let us study how do we solve when we have something like t power n into f of t. Okay. When we have the question in the form t power n into f of t. Okay. So the first step is write what is f of t. Yes. Find the Laplace of f of t. You would get f bar of s. Yes. Now, the second step is what? Laplace of t power n f of t. This is equal to minus 1 to the power n d by ds n and n f bar of s. Okay. Now, let me take a question and solve accordingly. Yes. Say, first one. Yes, first one, find the Laplace of, okay, find the Laplace of t sine 4t. What is Laplace of t sine 4t? The first step is, write down what is f of t. We have t, observe the first step, we have t power n into f of t, right? So we have here t into f of t. F of t is what? Sine 4t. Yes. Now, what is Laplace of f of t? Laplace of f of t is equal to Laplace of sine 4t. What is Laplace of sine 4t? That is 4 divided by s square plus 4 square, which is 36. Okay, this was our first step. Now, for the second step, what are they saying? That is Laplace of t power n, that is t power 1 into f of t, that is sine 4t. This is equal to minus 1 to the power, see, in the place of n, in our question we have 1. Yes, so let me write that as d by ds. What is f of s? Yeah, this is our f bar of s, right? That is 4 divided by s square plus 36. 4 is a constant. I can take it out. What is differentiation of 1 divided by s square plus 36? Basically, what is differentiation of f divided by g? The formula is gf dash minus fg dash divided by g square. Okay. Now here in the denominator, I have s square plus 36. If I differentiate the numerator, I would get 0. So 0 in the denominator is 0 minus, what do we have in place of f? I have 4. And in place of g, that is the denominator, I have 2s divided by g square, that is s square plus 36 whole square. Okay. So I would get minus 4 into minus 4, that is plus 4. Okay, 4 into 4 into 2, right? So that would be, yeah, 4 4s are 16, 16 2s are 32 divided by s square plus 36, the whole square. So this is our answer. So how did I solve this? I have the question, that is t sine 4t. So f of t is sine 4t. Okay. Laplace of sine 4t is what? Laplace of sine 4t is 4 divided by s square 4 divided by s square plus 36. What is Laplace of t into sine 4t now using the formula? That would be minus 1 d by ds of 4 divided by s square plus 36. Now we are applying the quotient rule. Okay, what is the quotient rule? Differentiation of f divided by g is equal to gf dash minus, that is, keep the denominator, differentiate the numerator. When you differentiate the numerator, that is 4, the answer would be 0. Okay, so here you wouldn't get a 4. Let me change the numerator now. Okay, minus, yes, they are asking us to keep the numerator as it is, that is 4 into differentiation of denominator is 2s, because differentiation of 36 is 0. Yeah, so what would I get? Minus into minus, that is plus. 4 2s are 8s divided by s square plus 36 whole square. Okay, find the Laplace transform of, the second one is find the Laplace transform of t sine square t. Okay, what is the first step? The first step is write down what is f of t. Okay, what is f of t? F of t is equal to sine square t. Yes, now what is Laplace of this f of t? Laplace of f of t is Laplace of sine square t. How do you find Laplace of sine square t? We don't have any direct formula. Okay, so in the trigonometric formula list, yes, in one of the videos I gave all the formulas that we use from trigonometry. From one of those equations I'll take, that is 2 cos theta is equal to 1 minus 2 sine square theta. Now simplifying for sine square theta, what would I get? Sine square theta is equal to, if 2 sine square theta goes to the LHS, it would become positive 2 sine theta. 2 sine square theta, yeah. If 1 will remain as it is, if cos 2 theta comes to the RHS, it will become minus cos 2 theta. Now what is sine square theta? Sine square theta is equal to 1 minus cos 2 theta divided by 2. Okay, now let me substitute that sine square theta value, that is cos 2 theta or cos 2 t alva, t divided by 2. Can I take this half out? It is a constant, right? So I can write it as half Laplace of 1 minus cos 2t. Now I can apply Laplace to each term. So I would get half as it is Laplace of 1 minus Laplace of cos 2t. What is Laplace of 1? Laplace of 1 is 1 divided by s minus s divided by s square plus 4. Okay. So can I take LCM? If I take LCM, since denominator are different terms, I would just multiply s into s square plus 4. Then I would have to cross multiply. So I would get s square plus 4 minus s square. S square and s square gets cancelled. I would get 4 divided by, yeah, s cube plus 4s. Why am I doing all this? Because I would have to differentiate, right? The simpler the equation is, it will be easier for differentiation. Yeah, so Laplace of, what is the question? Question is t sine square t, right? T sine square t. The formula is minus 1 to the power n dn by dsn into f bar of s. Yes, this is our f bar of s. Agree? See, we have Laplace of f of t, right? Laplace of f of t is f bar of s. Basically means the question is in the form of t and the answer we are getting is in the term of, and the answer that we are getting is in terms of s. Okay. So now, what do we have in place of n? We have 1, right? Observe t power n alva. So that would be 1. So d by ds. What is f bar of s? That is 1 divided by 2. 4 divided by s cube plus 4s. Okay, now if I take half common, it would be minus 1 divided by 2 d by ds of 4 divided by s cube plus 4s. How do you differentiate this? Whenever you have in the numerator constant, directly write it as 0 minus. Okay, when you're differentiating. What else? I should keep 4 as it is now. Differentiate the denominator. That is 3s square plus 4. If you ask me how did you get this, use the formula. Yeah, which formula? I had written in the previous problem, right? Yes, I'm using this formula. Okay. Now, getting back to our problem. 3s square divided by 4 divided by s cube plus 4s the whole square. So what is the answer? Minus into minus plus. 2 ones are 2 twos are. Yeah, 2 ones are 2 twos are. So I would get 2 3s square plus 4 divided by s cube plus 4s the whole square. Okay. Now moving on to our next question. Yes, find the Laplace transform of t square into e power minus 2t. Okay, e power minus 2t minus, yes, minus cos 2t plus 4. Okay, how do you solve this? First, let me multiply t square with each term. T square cos 2t plus 4t square. Okay, what else? Now let me give Laplace to each term. E power minus 2t minus Laplace of t square cos 2t plus Laplace of 4t square. Okay, now here you see you have t square into e power 2t. You can apply either, you can write t square e power 2t as e power 2t t square 2. It means the same because it is commutative. Okay. So in the shifting property, how was our shifting property problems? It was in the form of e power at into f of t, right? And the other one, t square e power minus 2t, this was in the form of t power n into f of t. Yeah, so the same question what I've written here, that is the Laplace of t square e power minus 2t, you can solve it in two ways. Either apply the shifting property, that is the first property, or apply the second property. You will get the same answer. Yes, now let me apply the shifting property. Why? Because it's easier, right? Let me erase this. Yeah, so I'll apply shifting property. For the first one, that is Laplace of t square e power minus 2t. If you apply shifting property, I'll just rewrite it as minus 2t t square. It means the same. Okay. What is f of t? F of t is t square. What is Laplace of f of t? Laplace of f of t is 2 factorial divided by s to the power 2 plus 1, which is s cube. Okay. Laplace of f of t is 2 factorial divided by s cube. Okay, this is equal to what? F bar of s. In shifting property, after finding Laplace of f of t, if this was the first step, what was the second step? It was to find f bar of s minus a, right? Wherever you have s, you just replace it with s minus. What do you have in place of a? Observe. See, for shifting property, the question should be in the form of e power at into f of t. Compare these both now. In place of a, I have minus 2. Agree? So in place of a, I would have to write minus 2 into minus whole cube. So our answer is 2 factorial divided by s plus 2 the whole cube. Okay. Now moving on. Let me try solving this, the same Laplace of t square e power minus 2t. I'll solve this using the second property. What was the second property? Take f of t as e power minus 2t. Yes. What should I do next? Find the Laplace of this. What is Laplace of f of t? Laplace of f of t is 1 divided by s plus 2, which is equal to f bar of s. Now, what is the formula? The formula is, that is, Laplace of t square e power minus 2t is equal to Laplace of, the formula is minus 1 to the power n. In place of n, I have 2. So, minus 1 whole square, d square by ds square. Yes, d square by ds square into f bar of s. Okay, what is minus 1 whole square? It is positive 1. What should I do? D by ds square of 1 divided by s plus 2, right? What is the differentiation now? So that is d by ds of first derivative is differentiation of, in the numerator I have constant, so I'll directly write it as 0 minus, keep 1 as it is, and differentiation of denominator is again 1 divided by s plus 2 the whole square. That is nothing but minus 1 divided by s plus 2 the whole square. Now again, if I differentiate, what will I get? Differentiation of this would be, numerator is 0, right? Denominator would be minus of, numerator would be as it is. Differentiate the denominator, that is 2 into s plus 2. And differentiation of s plus 2 is again 1 divided by s plus 2 whole power 4. So I have minus into minus plus 2 s plus 2 divided by s plus 2 whole power 4. So this cancels and you get minus 1. Answer is 2 divided by s plus 2 whole cube. Did I get the same answer? Let me check. See, 2 factorial is 2, right? 2 divided by s plus 2 the whole cube. You either apply shifting property or you apply the second property where you differentiate. You will get the same value. When do you have this choice? When you have t square into e power minus 2t. Okay. Moving on, we should find out what is Laplace of t square cos 2t, right? Laplace of t square cos 2t. So what is first step we should find? Here, let me write down Laplace of t square cos 2t is equal to, first write down what is Laplace of cos 2t, that is Laplace of f of t, s divided by s square plus 4. What is the next step? Write down the formula, Laplace of t power n cos 2t, this is equal to minus 1 to the power n. What is the value of n? N value is 2 here. D square ds square of s divided by s square plus 4. Minus 1 whole square is 1. So d by ds of the first differentiation would be, here in the numerator we don't have a constant, we have a s. So what I'll do, I'll keep the denominator as it is. Differentiation of the numerator is 1 minus, keep the numerator as it is. Differentiation of denominator is 2s plus 0, I'll write as 2s. Whole thing divided by s square plus 4 the whole square. Okay, what else do I have? I have derivative of s square plus 4 minus 2s square divided by s square plus 4 the whole square. Okay, so d by ds of minus s square plus 4 divided by s square plus 4 the whole square. Now let me find the last derivative. That would be, keep the denominator as it is, differentiate the numerator. Differentiation of numerator is minus 2s, okay, plus, keep the numerator as it is, that is 4 minus s square, okay, differentiate the denominator, that is 2 into s square plus 4 into 2s whole thing divided by s square plus 4 whole to the power 4. Okay, now what else is remaining? Minus 2s s square plus 4 whole square plus 4s into 4 minus s square plus 4. Can you take s square plus 4 common? You can take it common, divide it with the denominator, yeah, and you can simplify this step further. Okay, do some simple math. What is the third term? The third term is find the Laplace of what? 4t square, right? So let me write down the answer directly. That would be the Laplace of, yeah, Laplace of t square e power minus 2t. What we found was 2 factorial, that is 2 divided by s plus 2 the whole cube minus, what was Laplace of t square divided by cos 2t? That was something like, yeah, so I would get, I have a negative sign, minus 2s. Okay, if I take out s square plus 4 common and cancel out, I would get s square plus 4 plus 4s into 4 minus s square divided by s square plus 4 the whole cube. Yes, what is the third term? The third term is find the Laplace of 4t square, right? Laplace of 4t square would be, yeah, plus Laplace of 4t square is what? Take out 4, it is constant. Laplace of t square is n factorial, that is 2 factorial divided by s to the power 2 plus 1. So that would be s cube. Yes, so what did we study in this lecture? We studied, or we solved, Laplace transform of which type? If you have the question as t power n into f of t, we use this method, that is first identify f of t, find the Laplace of that. You would get f bar of s, and Laplace of t power n, f of t formula is the second one that I've written here. Yes, you just substitute this. Be careful while identifying the value of n. Okay, so the first question was a simple question, right? Directly I wrote f of t as sine 4t, and Laplace of f of t was 4 divided by square plus 36, and then I differentiated it. In the second question, I applied first sine square t formula, a trigonometric formula, and then I found the Laplace of that. Then I differentiated it. Yes, the third question was, first I had to remove the brackets. Then I took Laplace of each term. In the first term, we had an option of applying both the second property and the shifting property. We observed using both the properties, we would get the same answer. So in the exam, you can use any property of your choice. You will get the same answer if the steps are correct. Okay, and then for the second term, it was direct, right? F of t, we just applied Laplace to f of t, and then we differentiated it twice. Why? We had t square. If you have only t, you would differentiate it once. If you have t square, that is if n value is 2, you differentiate it twice. The third Laplace was direct, right? We have only Laplace of t square. For Laplace of t square, we have a direct formula. That is Laplace of t power n. What is Laplace of t power n formula? Laplace of t power n is n factorial divided by s to the power n plus 1. So in place of n I had 2. I substituted that. Okay, that is it for today's class. Thank you.